Hello and welcome to this webinar on error handling in Dialog APL. This is part 3 of this series on error handling. In the previous webinar, we have gotten over the very basics of error trapping, including the trap control structure and error guards in defense. We have looked at the error number and the corresponding error message that can be used to look at what went wrong after an error has happened. We have used Apple Cart for finding the error numbers corresponding to a particular type of error, and also for looking up error numbers and their meanings. In part 2 of the series, we looked at the more advanced form with quad trap, where you could do things you couldn't do with the other forms of error trapping. And we also looked at quad DMX, which was a namespace containing details of the error that happened. We looked at Apple Cart as to how you can pick out all the pieces of quad DMX to reconstruct the full error message that APL shows you when an error happens. You can find these 2 webinars on dialog.tv. Today we are going to look at raising an error by yourself. That is, you have some code that detects a certain condition, and then it needs to send a signal to its caller or to the APL user, if they're using it interactively in the session, that something has gone wrong. And we're going to look at how you tell that level above you what has gone wrong, the same way that the APL primitives can tell you about what has gone wrong. Once we've had that sorted, then we're going to look at use cases for this system. The first thing we're going to look at that is how to check whether certain conditions hold true and then signal that it doesn't hold true if that's the case. And these things can be used in QAs as well. And finally, we're going to look at how to detect an error but decide that you don't want to do something about this error, rather let it bubble up one level to the caller above you. Without further ado, signaling an event. Let's say we have this utility function that computes the arithmetic mean of a given vector. Now, if you apply it, of course, you get the mean as expected. But if you apply it on an empty vector, you get a surprising result, 1. This is because the sum over an empty vector is 1, and the sum over an empty vector is 0, and the length of an empty vector is also 0. And by default, in APL, 0 divided by 0 gives 1, so that all numbers divided by themselves give 1. And there is a side to say that it should give 0 instead, as in there are no numbers in this collection that would cause the mean to deviate from the origin point from 0. And in fact, there is a setting you can set such that 0 divided by 0 gives 0. But really, for something like the mean, no value is very useful. And it would be better to tell the caller that they have done something that doesn't make any sense. You cannot get the arithmetic mean of an empty vector. So if you could get a domain error, that would be nice. Maybe even just like when you divide by 0 normally, you get a division by 0 error. It would be nice to give some details of that. We could also go one step further and customize the error message to tell the user exactly what has gone wrong. Say this is a mean error, and the reason for the mean error is that the first axis is empty. For this purpose, and for everything we're going to do today, we are going to use the quad signal system function. Now, quad signal's basic syntax is that it takes a scalar as argument. The scalar, however, is not necessarily simple. It can be a simple number, in which case it's just the error numbers that we have covered in previous webinars. It can also be a scalar which contains name-value pairs, but we'll come back to that. Let's first look at the error number. So for the error number, let's say we put in error number 11, which we've met before. That's the domain error. Now when we call the function with the empty vector, we get that domain error. It's really that simple. Let's go over then to the name-value pairs. This is where the real power lies. Now, name-value pairs, if you think back to the previous webinar, we looked at QuadDMX and how you could use this trick with QuadJSON to expose all the contents of QuadDMX. It looked something like this. And if we look at this really carefully, we can actually see that it's a namespace, consists entirely of names and values. We could also represent this as a table. In fact, Resignal can handle a 2-column matrix as well as a vector of 2-element vectors. But for now, we're just going to deal with the 2-element vectors. So taking this knowledge back again with us, we can then look at what it is we want to expose in QuadDMX. We want the error number to be 11 because it is a type of domain error. And the basic error message we want to be this mean error, and the extended message is that specific message for this problem. Now we can take this and package up these names and values into 2-element vectors, then packaging that whole vector of 2-element vectors into the scalar and feed it to Resignal. Let's take this and put it into our mean function. Now we have the condition. If the argument is empty, then we're going to throw this error with all these details in it. And indeed, you can see that it works quite fine. So this is the basic syntax of Resignal. There are a lot of details in what exactly you can specify. You have to at least specify the error number, which would then be the same thing as just Resignal with a number after it. And there are some things you're not allowed to specify, but the things that are interesting you can. So let's put this into practice. The first thing we're going to do is the assert function. It's now more than a decade ago that Roger Huey came up with the assert function in this particular formulation we're going to use today. It was right when defense were new, and he has been using it ever since, especially in writing QAs and models for various things. Through that, it has become somewhat of a standard. You don't have to remember it by heart. applecart.info to the rescue. And later this year, we're going to release version 18.1. It's going to include an applecart user command that's going to make this easier. Okay, moving over to applecart for now. We can type in here assert, and that gives us exactly one result, which is Roger's formulation of the assert function. So don't worry about exactly what it says now. We just take this and copy it and bring it back with us, and this is what it looks like. I think Roger has always been writing it on a single line with diamonds, but you don't have to. You can break it up onto multiple lines like this. As long as you have the final brace, closing brace, at the same line as that shy gets. And we're going to go through all the technicalities of this function. Why is that? Because even though an assignment in a defin like this causes it to be shy, then the value can still be used going through. But that's only if it's the last statement in the function. If there are additional statements, and that would mean any line break after that gets 0, would be equivalent to have the diamond here, then if you try to use the value, you get a value error instead. So important to have that final brace on the same line as the shy gets 0. The real action is happening here on the middle line. Assert works like this, that it takes it's put on the left of a condition, or it could also be multiple conditions. What I mean by condition, normally it would be something like this array matches that array. It could also be that a bunch of elements are equal to a bunch of other elements, or greater than, or in some range. It has to be something that returns a Boolean array, and all of the results, all the elements of that array, the argument to assert, have to be true. Now, if any of them are not true, that is, if there are any zeros, so that's what the 0 member of omega does, then we continue with quad signal 8. And it doesn't necessarily have to be 8, but it has become basically a de facto standard where people use number 8 for assertion failures. The number isn't really used for anything else. You might spot something interesting here, that we are using quad signal dyadically with alpha as left argument. And we haven't seen that syntax before. However, it's really simple. If you want to give some details for quad signal, and the only things you want to give are the error number and the basic error message, then you're allowed to use the shorthand where you put the error message on the left and the error number on the right. And that's what we're doing here. And finally, at the very first line, we have alpha gets. And what this does is it sets up a default left argument. This means that you can write just assert and some conditions, and if the assertion doesn't hold, then we're going to throw an error number 8 with the error message assertion failure. However, you can be more specific about the test. So, for example, if your test is that some value is within the range, then you could give a left argument to assert, which is argument out of range, or possibly even say what the range should be. The way these default left arguments work is like this. Let's say we have a function that does this assignment to alpha. If we call this function with a left argument, then that entire statement is skipped. And so we get 2 times 3 is 6. And if we call it monadically, then we do execute this statement, and alpha becomes 10, and the result is 30. And that's exactly what's happening inside the assert function. And so that alpha goes down and becomes the left argument to quad signal. And finally, the shy result, as I spoke a little bit about before, when you have a function, then we get the result. If you assign the value as the last statement, then it appears to not have any result. But if you try to use the result of such an assignment, then you still get a value out. And even though the function as a whole doesn't display anything, it does return a value that you can use outside the function as well. So that's the assert function. This is the way that Roger Hugh has formulated it. It's really useful. But it doesn't have to look exactly like this. You can, of course, customize it as you want. You could add functionality so that you can have more details on quad signal to populate other parts of quad DMX. You could add other types of conditions as well. Let's take it and stick it into our mean function and look exactly at what the syntax looked like. Notice there's a colon here at the line at the end. So the way this works is in a defin, the first statement, which is not an assignment, causes the defin to terminate with that value. So even though it might look like here we're computing 0, which doesn't do anything, and then we should return omega, in fact we return 0. However, if you have a colon there, then that's a guard, which means what's on the left of the colon is a condition. It has to evaluate to 0 or 1. If it evaluates to 0, then the guard doesn't trigger, and whatever is on the right side of the colon doesn't get executed. Rather, execution continues with the next statement. If it was a 1, we would stop there, and if there was anything on the right of the colon, it would be returned. So here, with a 0, we go further to the omega. Another way you could do this instead of the colon would be to assign the value to a dummy error. And we could have used that here, but it's much neater to use the colon. Okay, this is for a defin. In a tradfin, you take away that colon. Now, we saw that assert was returning a shy 0, and that was used as the true-false value for the guard, causing the function to continue. In the defin, instead, we're not using the fact that assert returns a 0, we're using the fact that assert is shy. And that's because in a tradfin, any value that's not being assigned would normally be displayed. But a shy value, that's why it's called shy, doesn't display. You can only use it for something else. So this very clever formulation of assert allows you to use pretty much the same syntax in a defin as in a tradfin. And a real-world usage, in the APL problem-solving competition from last year, one of the submissions included a set of tests for the submission itself. This is the function to test the Assert function. And we can see here that assert is being used with some test cases in calling the Assert function. And it comes out pretty nicely with a colon here. This isn't special defin syntax. This is just normal defin guards. And it says, right, assert that 8 equals to Assert 3. And then, if that holds, colon, continue with this, and then assert the next thing. And if all the things hold true, then the function returns test passed. If any of these tests fail, then the QA function here would suspend on the statement where the failure happened, and you could have a look at what exactly went wrong. If you want to see the further usages of assert in the student competition, in the problem-solving competition, then you can find a blog post about last year's competition at is.gd/APL 2020. And now, finally, for another utility function, which is to resignal errors. Here we're going to use a different example. This is a utility function for counting the number of lines in a text file. So we're getting the file out, the content, as a vector of vectors, and then we count it. We apply that, and we get a count. But let's say we call the function on a file name that of a file that doesn't exist. Then we get a file name error, and the name of the file that's problematic and what the problem was. But we also get a pop-up from APL, a tracer, saying that things went wrong at the statement of quad get. Now that's fine if you are debugging things and want to fix your code and maybe you had the wrong file name. But if you were to distribute this lines function as a utility function for others to use, you might want it to behave a bit more like an APL primitive. That is, it shouldn't suspend and open the tracer and show its ugly innards and what's going on inside. It should simply tell the user, I can't do this because I couldn't find the file. And there could be all kinds. It could be you couldn't find it. Could be that the file system isn't available. It could be that you don't have permission to read this file. So it doesn't really matter what the condition is. And in either case, we just want whatever problem was to be signaled further up the stack. Normally, I wouldn't recommend using an error trap with the code 0 because it's too big a grip. 0 meaning all errors. But when it comes to things like getting files where all manner of things could go wrong, then 0 might very well be the right choice. So this says, if anything at all goes wrong in the following code, then quad signal something. How do we get all the details of the error that happened and propagate them up with a new raising of an error? And for that, Apple Cart to the rescue. So go to Apple Cart, and we write resignal, and we find this very long and complicated expression. If you dig into it, you'll see that it's really just picking out pieces of quad DMX and throwing them at quad signal again. But don't worry about it for now. Take the whole thing, copy it, and move it into our function. And now, when we run it, then we can see that execution got suspended. We don't build up a stack. We don't get a tracer window. We just have the caret pointing at the lines function saying that this is where things went wrong. And for all purposes, the lines function looks like it's a built-in. So we have used this to kind of extend the language without exposing how it actually works inside. It doesn't mean the user cannot look at it. If they open up lines in the editor, you can still see it, which is different from a traditional way of doing this, of locking the function, which means you can't look at it anymore. Now, if you do this a lot, then you might want to define this resignaling as its own function that you can call, so you can use it everywhere. And you might think, oh, I don't need to take any argument, so a niletic, that's a no argument, threadfin will do the trick. But there's a problem here. If you try to apply this lines now, then you can see that since the error was raised by the resignal function, then it is as if the resignal function is the built-in, and we still get a suspension inside the lines function. And you might think that instead then we can trick the system by writing a defin, a one-liner defin. You might know we cannot suspend inside it, but that would be a mistake as well, because it's not the problem that we're suspending inside the resignal function. If you try to run it, we get exactly the same problem. And again, we get suspended inside lines, because yes, we did leave the resignal function, and that leaves us inside the lines function. So what can we do? Well, we look at this resignal function. It says quad signal and then some computed array, which is a scalar containing all kinds of things. Now we take the quad signal function and move it outside the brace. How does that work? Now it becomes a tacit function. It's on the top. It has two pieces. The right tine, the right part of the function, is a function that takes an argument but doesn't actually use the argument, and it then picks out the pieces that we need from quad DMX, constructs an appropriate argument for quad signal, and then it returns that. Then execution continues with the left side of the top of this tacit function, which is quad signal. Why do we want to do it with a tacit function like this? Because tacit functions have a very curious property in that they don't occupy their own stack frame. That sounds complicated. Let me show you. Let's say we have a function foo, which calls a function goo, and the function goo looks at quad si. Quad si is the stack indicator. It contains the names of all the functions that are on the stack at any given moment. So, by the time we call goo, we have goo on the stack and also foo on the stack. And if we instead use a tacit definition of goo, which we have here, yes, it looks complicated, and that's because we need to run quad SI, which is an array, not a function, so we have to jump through some hoops. But don't worry about the formulation. Just see there are no braces here, so this is a tacit definition. Then we can see that goo doesn't occupy any stack frame, and we only get foo. And now when we run lines, then it behaves the way we want, even though we're using the Resignal function. And those are the things I wanted to go through today. If you're participating live, then on Dialog.tv, you can ask questions in chat right now. I'll wait a bit to see if there are any questions. Meanwhile, here's a summary of the things that I went through today. There is the quad signal function. That's the only new function we use today. And it can either take an error number or a bunch of name-value pairs packaged into a scalar. We've seen the usage using Assert and Resignal, which you can find on Apple Cart. And you can get all the details of quad signal by typing quad signal into your APL session and pressing F1. I'll wait a bit to see if there are any questions coming in. The next upcoming webinars, we are continuing with Dialog webinars every other slot, so to say. So that's every 4 weeks. And BAA week, British APL Association's webinars every other week. The next BAA webinar is the annual general meeting, so it won't be a normal webinar, but it might be interesting to see what's happening with BAA and where they're going. Devin asks if Resignal can also pass the dummy right argument to the defin. Yes, so if we go back and look at the Resignal function that we had here, can take this away, then we can see that we need to return. Right, so this is the tacit version. We need to return a result from the right side of the right tine of the tacit function, which is the appropriate argument to quad signal. And so, what Devin is asking is this tilde, this empty vector here, could it be some kind of argument that we could potentially return to the defin further over here, I think. And that doesn't really make so much sense, because anytime we proceed over here, quad signal is going to stop execution, and there's nothing we can do. However, we could have used some kind of argument here, which had some interesting information from the function over here, and that information could be packaged into quad DMX somehow for further analysis. That answers the question. So, if that's it, then thank you very much. I will be with you in the chat shortly. All the best.